Hello everyone. Thanks for being here with me. My name is Paul. I'm an engineer here at Prosthetic Design, and today I want to share with you our PDI Squirt Shape 3D printer. The Squirt Shape printer was built and designed to print lower limb prosthetic sockets. It can make other things too, but more on that later. First, I want to dive into how the printer can change the way a practice operates. The printer can speed everything up, from how everyone in the practice spends their time and just how much faster a patient can get from an initial consultation to a definitive leg. From start to finish, on average, a transtibial socket will take an hour and a half to complete printing, and a transfemoral socket will take 2.5 hours to complete printing. This lets a prosthetist make a check or definitive socket in just 2 to 3 hours. And while the socket is printing, time can be spent doing other important tasks, like paperwork, taking notes, finishing other sockets, or even seeing other patients. These are just a few changes that can take place to help with productivity. Getting a patient into a definitive socket and up and moving can be achieved so much faster. The printer keeps the patient from having the chance to fluctuate in size between fittings, letting definitive sockets fit consistently better. If a patient needs to start therapy, maybe they are a new amputee or someone who hasn't been able to walk for a while, they're able to quicker. If an issue arises for a patient, it can be addressed with the printer. And in the worst case scenario, you would be making a new socket, but only in a few hours. Manufacturing sockets at this speed doesn't mean there is a trade-off in the type of sockets that can be made. You can make small pediatric transtibial sockets, large transtibial sockets, pediatric transfemoral sockets, large transfemoral sockets, or any size in between. Transtibial designs like a PTB socket or total surface bearing, vacuum or suction socket, are possible. Transfemoral designs like an ischial containment style with a lanyard suspension or a quad design with vacuum for suspension can easily be made as well. Using the printer won't limit how you fit your patients. It can allow for more creative shapes and increase willingness to try new things. Speaking of new things, check sockets off the printer will be a change, as printed material is an opaque white polypropylene. When fitting transtibial sockets in our in-house clinic, if there are pressure points felt by the patient, a small, flat LED is used to mark the spot on the limb and can then be translated to the socket. When fitting transfemoral sockets, quarter-sized holes are drilled into the socket, and these let the prosthetist see where there are tight spots or loose spots. This alters the fitting process, but can give you the same results as a clear check socket. All check and definitive sockets are made in the exact same way, and if the socket was previously printed, it can literally be replicated. The printer makes reproducibility easy. When making sockets with the printer, each starts with a distal cup. All the distal cups are precision machined to have a smooth bottom surface and the standard European 4-hole pattern. So if any vacuum or suction attachments need a surface to seal, they can, and the standard European 4-hole pattern allows for the vast majority of all attachment components. There is a pre-drilled hole on the side of the standard height distal cups, designed to hold shuttle locks and vacuum locks. There are also low-profile cups that are made to fit simple connector plates, vacuum or not. So whatever your suspension needs are, there is a distal cup to start your prints. the printer might seem intimidating, or a tool that will take way too long to learn to be worth it. But as someone who has learned to use the printer, if used for a few weeks, anyone can be proficient enough to use it. From personal experience, when I started, I was trained for 2 weeks, and then my trainer went on vacation. So by week 3, I had just the manual, and sure, was slightly cautious, but survived and easily printed many sockets. Training someone to post-process or finish the socket also won't take a long time, as the material of the socket never changes, check, or definitive. This lets the person finishing the socket become familiar quicker. Someone who has already practiced in socket manufacturing and post-processing will only take a few sockets before they are a pro. Any modifications that can be done in a thermoform socket can also be done on a printed socket. So whether you are a veteran or a rookie, the printing of sockets and the finishing of them won't take any time at all. Also, if a patient wants an aesthetic change to their socket, the printed socket can be laminated over. The only difference from a traditional lamination is that the socket becomes your internal mold instead of plaster. Otherwise, the process is very similar. Props to everyone that does this the traditional way though. I have personally had to laminate over a few of our sockets, and that was a lot of work. And I don't even have to deal with the plaster. The printer lets me work smarter, not harder. I want to speak a little now about how the printer has changed our in-house practice and some things that might be unique to us. Remote. The printer has let our clinic help people remotely. As a small clinic in Dayton, Ohio, we have fit patients all over the globe, from North and South America to Europe and Asia, all of whom we have never had in the clinic. Locally, our prosthetist is able to do in-home visits as well. We can make 2 or 3 check sockets and take them to a patient who would never be able to make it into the clinic. The printer makes this a viable business model, with the plus that we can help another patient, and it lets us reach more people and help those that have a hard time getting help themselves. I mentioned at the beginning that the printer can also make other things, and one of our main uses is for custom liner manufacturing. We use the printer to make 2-piece molds for the liners. The outer portion of the mold is printed on a distal cup, just like our sockets, but the inner mold has one change. It is printed onto a distal cap instead of a cup. This gives the liner a distal shape similar to any standard off-the-shelf liner. The 2 molds slide together, and the silicone liner material takes shape of the empty volume between the 2 molds, creating the liner. This gives many of our atypical shape or skin-sensitive patients the ability to have a well-fitting liner, improving their overall outcome. I have a few other numbers to show how having the printer can really change the speed of a practice. In just 6 months, our 1 prosthetist and 1 technician were able to complete 453 prints, and there were even some workdays where no prints were made. Now bear with me for a second, I'm going to do a little math, but the question I want an answer to is how long would it take to make 1,000 sockets, with 500 being transtibial sockets and 500 being transfemoral sockets? Using the average print times of 1.5 hours and 2.5 hours for transtibial and transfemoral sockets respectively, it would take 4 hours to print 1 of each. Then, assuming an 8-hour workday, the printer could make 2 of each, or a total of 4 a day. Now, just divide 4 into 1,000, and we get 250 days to print 1,000 sockets at a 50-50 ratio. In 2021, there are 261 workdays. Now, this is without holidays and vacation and personal time, but it would be possible to print over 1,000 sockets in a year. the Squirt Shape printer can do many incredible things, and I just want to emphasize how much this manufacturing process can speed everything up for a practice and for a patient. So why walk when you can drive? I want to thank everyone who has been able to listen to me today. I appreciate it very much. The printers are available for purchase, and we also do central fabrication if you would like to try one of our sockets yourself. We have more videos of the printer on YouTube if you want to check them out. Visit our booth to see more of what we can help with, and feel free to ask any questions you might have. We would love to hear from you. Our general manager Bob will be there for any customer service and business related info, and our prosthetist Brad will be there as well for any clinical questions. And once again, thank you, and have a wonderful rest of your conference.